In this video, we are going to discuss some important numericals. Let's go for discussion. Numerical number 1. Numerical number 1. It is claimed that it is claimed that 2 cesium 2 cesium clocks 2 cesium clocks if allowed to run for 100 years. To run for 100 years free from any disturbance many differ may differ by only about 0.02 seconds. What does this full stop? What does this imply? What does this imply for the accuracy of the standard cesium clock in measuring a time interval of 1 second? Question mark. My dear students, once again I am repeating the question. Listen carefully. It is claimed that 2 cesium clocks, if allowed to run for 100 years free from any disturbance means gravitational force disturbance and frictional disturbance and chemical reactions with air, whatever it may be, may differ by only about 0.02 seconds. What does this imply for the accuracy of the standard cesium clock in measuring a time interval of 1 second? This is the question. Now go for the Solution. Error in 100 years. Error in 100 years is equal to 0.02 seconds. 0.02 seconds. 0.02 seconds. Error in 1 second. Error in 1 second is equal to 0.02 second whole by 100 years into 365 by 1/4 of days into 24 per day into 60 into 60. Okay? Now, once again, I am repeating the point. Error in 1 second is equal to 0.02 whole by 100 into 365 1/4, because per 1 year 365 days of 1/4, like that 4 years 365 1/2 365 1/4 365 1/4 365 1/4, like that 4 years. After 4 years this 1/4 1/4 1/4 added gives a leap year. Okay, so 365 1/4 into per day 24 hours, per day 60 minutes, per minute 60 seconds. So finally we will get 7.9 into 10 to the power of minus 13 seconds. That is approximately equal to, I already told, this is approximately equal to 10 to the power of minus 12 seconds. Okay, so we have to, therefore error in 1 second is equal to how much? 10 to the power of minus 12 seconds. So negligible. That is why cesium clock is very accurate for the measuring the time. Now, numerical number 2. Numerical number 2. Estimate the average atomic mass density, atomic mass density of a sodium atom, of a sodium atom, comma, assuming its size to be 0.5 angstroms. Compare it with Compare it with density. Compare it with density of sodium. Sodium in its crystalline phase. Crystalline phase, that is 970 kg meter to the power of -3 full stop are the two densities are the two densities of the same order of magnitude question mark. If so, why? This is the question mark. Now, once again, I am repeating the question. Estimate the average atomic mass density of a sodium atom, assuming its size to be 2.5 angstroms. Compare it with the density of sodium in its crystal phase 970 kg meter to the power of -3. That means it is density. Are the two densities of the same order of magnitude? If so, why? This is the question. Now, go for solution. Atomic volume is equal V is equal 4/3 pi r cube n, that is equal 6.023 into 10 to the power of 23 meter cube into 4/3 into 22/7 into 1.25 into 10 to the power of -10 whole cube. Okay, now n is equal 6.023 into 10 to the power of 23 and 4/3 as usual I've written here. Pi I've written as 22/7. R is equal to already given 1.25. Now, why we took here 1.25 into 10 to the power of -10 whole cube? Because this is the diameter. We want to convert into radius. Radius of angstrom is equal to 1.25. So 1.25 angstroms we converted into meters. That is 1 angstrom is equal to 10 to the power of -10 meters. Okay, that is why here I wrote into the meters. Now, therefore, we get 4.0 93 into 10 to the power of minus 6 meter cube. Okay, this is the atomic volume. Now, what we want? We want average mass density. Therefore, average mass density is equal to, what is the formula? Mass by volume. Rho is equal to mass whole by volume. That means rho is equal to m by v. That is equal to 23 into 10 to the power of minus 3 whole by 4.93 into 10 to the power of minus 6. That is equal to 4.67 into 10 cube kg by meter cube. Now, therefore, density is equal, mass by volume is equal 4.67 10 cube kg by meter cube. Therefore, the two densities are not of the same order. This is due to interatomic separation. This is due to interatomic separation in the crystal. In the crystalline phase. Now, once again I am repeating this point. Here, the density is called 4.67 into 10 cube kg per meter cube. The two densities are not of the same order. The reason is, this is due to interatomic separation in the crystalline phase. Okay, so like that we have to solve this numerical. Now we are going to discuss numerical number 3. Now, numerical number 3. Now, a laser is a source of very intense monochromatic and unidirectional unidirectional beam, unidirectional beam of light. These properties these properties of a laser light can be laser light can be exploited to measure long distances. To measure long distances. The distance of the distance of the moon from the earth. Moon from the earth has been already determined. Already determined. Already determined. Very precisely. Using a laser. Using a laser as a source of light. As a source of light. A laser light beamed. A laser light beamed. A laser light beamed at the moon. At the moon takes 2.56 seconds to return. After reflection. After reflection at the moon's surface. At the moon's surface. At the moon's surface. How much? How much It is the, how much is the radius of the radius of the lunar orbit, lunar orbit, lunar orbit around the earth, around the earth, question mark. My dear students, once again I am repeating the question. Please listen carefully. A laser, laser means light, light, a laser light amplification stimulated emission of radiation. The full form is laser. Once again, light amplification stimulated emission of radiation is a source of very intense monochromatic. Monochromatic means single wavelength light, only red, or the total light is only green. Such a single light we can call as monochromatic light. So the intense monochromatic and unidirection. Unidirection means no reflection, no refraction, no dispersion. All the light phenomena cannot be accepted. Only unidirectional or single direction. Beam of light. Once again I am repeating. A laser is a source of very intense monochromatic and unidirectional beam of light. These properties of a laser light can be exploited to measure long distances. The distances of the moon from the earth has been already determined very precisely using a laser as a source of light. A laser light beamed at the moon takes 2.56 seconds to return after reflection at the moon's surface. Full stop. How much is the radius of the lunar orbit around the earth? This is the question. Now, solution. Solution. T is equal to how much? 2.56 seconds. Now, velocity v is equal to 3 into 10 to the power of 8 meter per second. Now, therefore, distance from distance from earth to moon is equal to, consider x. Therefore, the formula x is equal to cv into t by 2. That is equal to 3 into 10 to the power of 8 into time 2.56 whole by 2. 2 means this one. So how much we will get? 3.84 into 10 to the power of 8 meters. Okay, this is the distance from earth to the moon. Now I would like to draw a diagram to make you this concept easily. Now consider, this is Earth. This is moon. Now a light, that is laser light, projected like this. This is laser light. Laser light means light amplification, stimulated emission of radiation called as laser light. This is a monochromatic light. This is a monochromatic light. Monochromatic light. So that was hit the moon. After that, how much distance it traveled? It traveled from Earth to moon. Now, once it reaches the moon, it will be reflected. It will be reflected and reach the Earth. Now, what is the velocity of light? That is 3 into 10 to the power of 8 meter per second. Now, the total time taken is t. The total velocity from here is v. Now, how much distance is taken? That is x. How much distance taken from Earth to moon is equal to x. From moon to Earth is equal to x. So, the total distance is equal to 2x. Okay? Now, 2x is equal to, what is the formula? Distance is equal to velocity into time. Okay? Therefore, that implies x is equal to velocity into time by 2. Get clarity? Therefore, we will get, what is the x value? 3.84 into 10 to the power of 8 meters. Now tell me, what is the x? X is equal to distance from moon to earth or earth to moon. How much? 3.84 into 10 to the power of 8 meters. Like that, we have to solve the numerical. How that formula came, I already explained. I hope you understood this numerical. Thank you very much for watching this video. Thank you.